Hello students, in the last session we have derived equations of motions using mathematical method. Now let's derive equations of motion using graphical method. So for that, let us consider an object of mass m moving with initial velocity u. After some time t, its velocity changes from u to v due to uniform acceleration a. Let's plot the graph. So the object is starting with initial velocity u. After some time t, its velocity changes from u to v. Let's name the sides. Let this be O, A, B, C, D and E. First, let's write the information we have. OA is u, initial velocity, whereas BC is v, final velocity. This final velocity, whereas OC is OC and AD is T, time. Okay, so we know that slope of velocity versus time graph gives us acceleration. Acceleration. Okay, before we find out the slope, let's write. We know that BC is equal to BD plus DC. Okay, BC is V. BC is V. Plus DC is nothing but OA. OA is U. So DC will also be, if OA is U, DC will also be U. So let's write U in place of DC. Let this be equation 1. Now we know that slope of velocity versus time graph gives us acceleration. So acceleration can be written as BD by AD. Because BD gives change in velocity, which is V minus U. AD is time. BD by T. So this will become AT is equal to BD. Second equation. Now if you substitute this value in this equation, you will get V is equal to BD plus U. V is equal to AT plus U. If you rewrite it, you will get V is equal to U plus AT. This is first equation of motion, which is also known as velocity-time relation. Now let's derive second equation of motion using the same graph. We know that area under the curve of velocity versus time graph gives us displacement. So the displacement will be given by area of this trapezium OABC. I have drawn a line to divide trapezium into two parts. Area under the curve of velocity versus time graph gives us displacement. So area of trapezium OABC can be written as area of rectangle OADC plus area of triangle ADB. Area of rectangle OADC, for this the formula is OC into TC. Whereas for area of triangle ADB, the formula is half into AD into BD. OC is time and BC is initial velocity plus half into AD is again time and BD is nothing but change in velocity, which is V minus U. So this can be written as UT plus half into T into V minus U. We know from the first equation of motion that V minus U is equal to AT. So let's substitute AT in the place of V minus U. Then we get UT plus half AT square. This is second equation of motion, which gives us relation between position and time. Now let's derive third equation of motion using the same graph. So we know that the area under the curve of velocity versus time graph gives us displacement. So this is nothing but area of trapezium OABC. So displacement is nothing but area under the curve of velocity versus time graph, which is area of this trapezium. Area of trapezium OABC. For this we have a direct formula, which is half into sum of parallel sides into perpendicular. This will be half into, the parallel sides are OA and BC. And the perpendicular is OC. OA is nothing but U and BC is V, whereas OC is T. We know that acceleration is equal to V minus U by T. So from this we can obtain T as V minus U by A. Let's substitute the value of T in this equation. We get U plus V by 2 into V minus U by A. Now this is nothing but A plus B into A minus B. The formula is A square minus B square. So if you take 2A to this side, it will become 2AS, and this will be A plus B into A minus B, which is A square minus B square. So it will become V square minus U square. So if you rewrite this equation, we get V square minus U square is equal to 2AS, which is the third equation of motion, which gives us relation between velocity and position. Now let's solve a few numericals based on equations of motion. Let's say a train accelerates from 36 km per hour to 56 km per hour in 10 seconds. We have to find its acceleration and distance traveled. So first let's write the initial information we have. Initial velocity of the train is 36 km per hour. Final velocity is 54 km per hour and time taken is 10 seconds. We know that acceleration is given by change in velocity by time. So here final velocity is 54 and initial velocity is 36. By time is 10 seconds. This will be 18 km per hour and time is 10 seconds. Because this is in kilometer per hour, let's convert this into meters per second. 18 into 5 by 18 by 10. So this will become 5 by 10, which is 0.5 meters per second square. Acceleration will become 0.5 meters per second square. Now we have to find out distance travelled by the train. From the second equation of motion we have S is equal to ut plus half at square. The initial velocity we have is 36 km per hour. So if we convert this into meters per second, we will get 10 meters per second. So initial velocity is 10 meters per second. So initial velocity is 10 and time is also 10. That's half into acceleration we obtained is 0.5 into time is 10 whole square. This will be 100 plus half into 0.5 into 100. So 100 plus 2 ones, 2 50s. 50 into 0.5 is 25. So the displacement will be 125 kilometers. Let's solve another numerical where a train is travelling at a speed of 90 km per hour. That is, its initial velocity is 90 km per hour. Brakes are applied to produce a uniform acceleration of minus 0.1 meter per second square. And we have to calculate the distance travelled by the train before it comes to rest. So let's write the initial information we have. Initial velocity of the train is 90 km per hour. Let's convert this into meters per second. This will be 90 into 1000 by 3600 because 1 kilometer is 1000 meters and 1 hour is 3600 seconds. This will be 5 by 18, 18 ones, 18 fives. So this is 25 meters per second. Since the train comes to rest, its final velocity will be 0. 0 meters per second. Now, using the third equation of motion, we can find out the distance travelled by the train before it came to rest. V is 0, U is 25 whole square and 2 into acceleration is, I changed this to 0.5 minus 0.5 into S. This will be minus 625 is equal to minus 1 into S. So distance travelled will be 625 meters. Distance travelled by the train will be 625 meters before it comes to the rest. So that's it for today class. Please practice the derivations using graphical methods that we have derived today without seeing. Thank you.